Talking about understanding application performance, I'll bring up just kind of a standard workflow that we use many times. Here, what we see on this particular view is a view of a multi-area OSPF network. So here you have multiple areas in each of these different POPs. That's what the different colors are representing. And then you have the dark blue that's connecting all of those different locations together for the backbone OSPF Area 0. Now, what a typical workflow would be is a troubleshooter, an operator, he's coming in, maybe you've got a complaint from a customer or a branch that there's a performance issue or the network appears to be down or degraded. What an operator would do is he'd take whatever information he got, whether it be an IP address, maybe it's a stub, maybe it's a location, be able to enter this in that starting and point and destination, and we'll actually then be able to highlight where that traffic is being delivered. So you can see here we have an issue, we're troubleshooting between Chicago and LA. And when I go in to highlight this, the dark green arrows are showing me the forward direction, the dashed arrows are showing me the return direction, and then I have this little tunnel icon. You see the little black upside down U's telling me that there's a TE tunnel that's actually controlling that particular traffic going up to the link. So that makes it very quick for an operator to see exactly what's going on. In this case, everything looks good. But many times our customers tell us they're troubleshooting an issue that may have happened an hour ago or 30 minutes ago. And how do you go back in time to see what was happening from a network perspective? Here in this case, what I'll do is I'll go and edit the time control. I'll move back time by 30 minutes here to see what was happening 30 minutes ago. The view here will update, and you'll see these little red links here that's telling you that there were some adjacency failures. We're actually looking at this from a logical standpoint, so we can say these devices were not able to route traffic during that time frame, and so the path actually changed from going directly from Chicago to LA to going over to New York, DFW, or to Dallas, and then back. Now, why is this important? The network reconverged, it's still delivering data, but what kind of impact did it have on the surface? On the service, I can drill in to this particular service path, and I can see here was my good path going directly from Chicago to LA. Notice the play button here. I'm now going to be able to play through the series of events that we've seen on this network and recorded it. So as I hit the play button here, we'll actually see that when that adjacency failure failed, the path there in gray, the new path in green goes out to New York and Dallas. And you'll see that the latencies are all pretty decent as that first change happens. But as we continue to play here, we'll actually see congestion as the traffic moves. It starts to congest this link between New York and DFW, starting to cause big latency jumps and really degrades the performance between Chicago and LA. This gives being able to see the actual utilization jump here from 45% up to over 90%, causing all kinds of congestion in the network. This gives the network operator the true understanding of what the root cause issue was. Yes, there was a problem because of congestion, and we can engineer around that path and solve that particular problem. So we're not sitting here wondering what the ghost in the machine was. We can actually understand exactly what action to take to go resolve this issue.
So, Matt, you're going back in time and looking at events that happened 30 minutes or an hour or a day before. Is that correct?
That is absolutely correct. And in fact, we can go back even further. Many of our customers, most of our customers, in fact, store at least 9 months to 12 months of history data. Some of our customers have stored almost a decade now that they just stored offline, and the system can actually pull it back into live memory and then be able to play through those events as well.